target 9D, okay, is going to be talking about the distinction between linear and exponential. So in target D, we are going to be able to distinguish between both of them. You're going to be able to know when it's going to be a linear function and when it's going to be an exponential function. Okay, so a little reminder, okay, linear functions are the equation of a line, okay, and that is written as, okay, y equals mx plus b. Okay, and remember in this situation, we find the slope and the y-intercept. All right, in linear functions, the slope is always either increasing by adding, right, or subtracting. Okay, that's for linear functions. Okay, exponential is a little bit the same. I mean, we'd have a rate, okay, rate of change, all right, which is the same thing as slope. The only difference is that my equation is going to be y equals a times that b to the power of x. Again, a is the initial, okay, it's like your y-intercept, okay, and b is that rate, okay, so that rate of change. However, for exponential, if you haven't noticed that the rate of change in this one is about percentages. Okay, exponential functions that we've seen is either going to be adding or subtracting based on that percentage number they gave us. And remember, if they give us exponential number, we have to switch it to a decimal, which is what we have been using for target C. All right. For exponential functions, okay, because of that percentage, I don't know if you remember, but percentage, okay, the word per, remember, I keep saying, oops, I said it before in all or the other word problems, especially the word problems. Per means multiplication. And because exponential functions talks about percentages, that means that the rate of change will always be a multiplication. All right, so for linear functions, you're either adding or subtracting. For exponential will be always multiplication. All right, I just want to give you a little example. What you're going to be seeing is that sometimes the rate is going to be decreasing, okay, and obviously decreasing for this will be dividing, okay, but we need to do the reciprocal of division, which is multiplication. So we need to do the reciprocal of the number that we're dividing. So just for example, if I'm dividing by 2, that's my rate. I'm technically multiplying by 1/2. What's the opposite of 2? Remember, 2 has an imaginary 1 because 2 divided by 1 gives me 2. The reciprocal of 2 over 1 is 1 over 2. You switch it, okay? So keep that in mind that when you're going to be dividing, you're actually going to have to be multiplying by the reciprocal of that number. All right, because remember, exponential is always multiplication, no matter what. Okay, so let's look at some examples since we know the difference between linear and exponential already. It says identify whether the tables below represent linear functions or exponential and justify your answer with a written explanation. Okay, so let's work with table A. Again, to figure out if it's going to be linear or exponential, we need to find that rate of change. So the slope, again, adding or subtracting is for linear. Multiplication will be for exponential. Multiplication or division. But remember, we're using division. We have to switch it to the reciprocal. All right, so for, as you can see, how do you find the rate of change? We're always going to find it within the difference between the answers. So f of x. Remember, f of x is your y, which is your answers, typically your total, right? We're going to find by finding the slope between that. So as you see, for 4 to 6 to 8 to 10 and 12, we need to figure out what's happening. Either you're multiplying or you're adding or subtracting, right? As you can see, 4 to 6, well, that's increasing. 6 to 8 is that's also increasing. The only way that your numbers will be increasing, okay, so let me put that in here. The only way that your numbers will be increasing, it will be if you're adding or you're multiplying. The only way your numbers will be decreasing, so going down, will be by subtracting or dividing. But remember, dividing, we're still going to have to multiply. Okay, so it's still multiplication. Okay, but we're just going to use the reciprocal of the number that you're dividing by. Okay, you'll understand once we have a few more problems. So 4 to 6 to 8, we're either adding or multiplying. Well, 4 times 1 gives me 4. 4 times 2 gives me 8. That's not it. 4 plus 2 gives me 6. 6 plus 2 gives me 8. 8 plus 2 gives me 10. And 10 plus 2 gives me 12. So that means that I'm adding by 2. So this is going to be a linear function. And my explanation is that it's increasing by adding 2. Alright, I'm going to do another problem with you guys. Okay, again, I need to find the rate of change. How do I find the rate of change? By looking at the numbers of your y's, which is in this case f of x. Okay, 16, 8, 4, 2, and 1. I notice that the numbers are decreasing. And again, decreasing that means that you're either subtracting or dividing. But we're going to switch it. Let's see. 16 minus 8 gives me 8. That's good. But if I'm subtracting by 8, it has to be true through the whole table. So 8 minus 8 does not give me 4. It actually gives me 0. So I'm not going to be subtracting. Let's try division. Okay. 16 divided by what gives me 8? Well, I know that 16 divided by 2 gives me 8. 8 divided by 2 gives me 4. 4 divided by 2 gives me 2. And 2 divided by 2 gives me 1. So in this case, it's going to be an exponential, okay? But remember, exponential is multiplication. You're dividing by 2, which means that we're going to multiply by 1/2. So my explanation this is that it's decreasing. It's decreasing by multiplying 1/2. All right, so those are the two things that we have to either look for. Are they adding or subtracting, or are they multiplying or dividing? But make sure that when we're dividing, we need to switch it to the reciprocal because we're always going to be multiplying for exponentials. All right, let's try question number 2 together. The first table, I have 1. It goes from 1, 2, 3, 4, and 5. Okay, the numbers are increasing. The only two options you have is adding or multiplying. So is this going to be a linear or exponential? And you need to explain to me why. All right, good. You should have noticed that it's adding by 1. Sorry. And it's true throughout the whole table. So this one is a linear. Okay, it's increasing by adding 1. All right, try the next one. You go from 15, 12, 9, 6, and 3. The numbers are decreasing. That means that you're subtracting or dividing. Which one is it going to be, linear or exponential? All right, good. You should have noticed that for this one, you're subtracting by 3 throughout the whole table. So because we're subtracting, that means that it's going to be linear. Why? Because it's decreasing by subtracting 3. Next one, we have 81, 27, 9, 3, and 1. Again, your numbers are decreasing, so you are either subtracting or dividing. And if you're dividing, you need to switch it. You need the reciprocal of that number that you're dividing by. All right, good. You should have noticed that. You're going to be dividing by 3 through the whole table. 81 divided by 3 gives me 27. 27 by 3 gives me 9. And 9 divided by 3 gives me 3. And of course, 3 divided by 3 gives me 1. So this is exponential. And again, my explanation is that I'm multiplying, okay, by 1/3. So it's actually multiplying by 1/3. Again, we're not using division, we're using multiplication at all times. You just have to do the reciprocal of that division. And the last one, we have 3, 6, 12, 24, and 48. The numbers are increasing. So are you adding or multiplying? It's going to be linear exponential. All right, you notice that you should be multiplying by 2 through the whole table. That means this is going to be exponential. And since it's already multiplying, I know it's going to be increasing by the multiplication of 2.